This is example 5. Check understanding 5A, the bottom of page 257. And this would be the first example that I would call not simple quadratic factoring. And it's not simple because the x squared term has a coefficient which does not equal 1. Right? In this case, A equals 2. And whenever A does not equal 1, then we're going to have to go through considerably more steps to factor this expression. Okay. So try to follow along here. There's several steps that we need to follow to make this work. Okay, first step, right? First step, we are going to multiply 2 times 12. Right? 2 times 12 is 24. Okay, now think of the factors of 24 that add up to 11. Okay, well, let's think of the factors of 24. We have 1 times 24, which obviously means it's negative 1 times negative 24. We have 2 times 12, which also means negative 2 times negative 12. We have 3 times 8, which means negative 3 times negative 8 would also work. And last, we have 4 times 6. So we also have negative 4 times negative 6. So this is the second step. Which pair of factors add up to a positive 11? And we see that it's these two numbers here. So there was step 2. Right? Step 1 was multiply the A times C, the first number times the last number. We got 24. Step 2, find the factors of 24 that add up to 11. They are 3 and 8. Step 3, right? Use those factors, use those numbers, right? 3 and 8, to rewrite the middle term, 11x. And you could either write it as 8x plus 3x or 3x plus 8x. It doesn't matter the order. But we're splitting up the middle term. Okay, we didn't change this expression. We just rewrote it so it looks a little different now. 3x plus 8x equals 11x. Okay, that was step 3. And now we're going to group the first 2 terms and the last 2 terms. 2x squared plus 3x plus 8x plus 12. Okay, that was step 4. Step 5. Factor each set of parentheses. Greatest common factor factoring. What is in common between 2x squared and 3x? Right? There's no factor in common between 2 and 3, but both terms have an x in it. Right? This has x squared. This has just 1x. So there's a common factor of x. All right, what do I get if I factor an x from 2x squared? I get 2x. What do I get if I factor or divide 3x by x? I get 3. Okay, next set of parentheses. What is the common factor between 8x and 12? Not just any common factor, but the greatest common factor. I mean, you could notice that 2 divides into both of those. The question is there a greater common factor? And there is, right? 4. 4 divides into 8 evenly, and it divides into 12 evenly. So I'm going to factor out a 4. Right? What's left if I factor 4 from 8x? And the answer is 2x. What's left if I factor or divide 12 by 4? And the answer is 3. Okay? Step 6, which is really the last step. You should notice now that in parentheses, you have the same thing, right? 2x plus 3. So the last step of this, the final factoring here, since there's a 2x plus 3 in both this term and this term, I factor that from both terms. And what's left is x plus 4. Excuse me on that parentheses. Okay, now, if you want to see how that we could FOIL that and get back to where we started, then go ahead and do it. First, x times 2x is 2x squared. X times 3 is plus 3x. 2x times 4 is 8x. And 3 times 4 is 12. Right? These two are like terms, so I can combine them. 2x squared plus 11x plus 12. So this is the same as this. So how many steps was that? That was 6 steps to factor what I would call a not simple quadratic. Right, so again, try the check understandings. You can look at the example above, which is the same, and try the check understandings 5b and 5c. 5b should be x plus 1 times 4x plus 3. C is x minus 2 times 2x minus 3.